Hello, class. So excited for you to be here with me today. Whew, it's been awesome. Almost the end of another week. I hope you're getting ready for Easter. At this point, it would be a shame, but I hope that you are enjoying the time with your family. I miss you, but I just wanted to give you an opportunity to take a second. So let's reflect on what we've talked about this class period. Okay, good. Awesome. That was awesome. We reflected on and nothing because we haven't done anything this class period. Sorry. All right, so in this lesson, we are going to talk about three things that are proportional when we deal with circles. Three things that are proportional when we deal with circles. One deals with chords, one deals with segments, secants. The third one deals with secants and tangents. So that's why it's important to know what those are. So first off, what's a chord? A chord has its endpoints on the circle. A secant touches a circle twice but goes outside the circle. A tangent touches just it once as it goes by the circle. Now, the first one we're going to talk about, the first type of proportion, is dealing with the chords. So if I have my circle and I have two chords in it, all right, that intersect, and I put a W and an X and a Y and a Z. Now, before we give you the answers, I like giving you the answers and giving the information. Let's talk about this for a second. Let's just say I made these into triangles. What would you know about those two triangles? That's true. There's some truth there. They both look about the same. Good. But watch carefully with me. How about this? What do we know about this angle here and this angle here? They're going to be what? Those angles are going to be congruent. Very good. Well done. So we know those are going to be congruent angles. Now, what else can we prove about these triangles? What else can we know for sure about these triangles? Well, it is going to be important, but you can see it. Watch carefully. Let me dot this for you. See that? What do you see? This angle here is half of that, correct? But it's also half of that one there. So what do you know about those two triangles now? You know that those two triangles are similar. Good, so that means that everything about them is proportional. So therefore, the W has to be proportional to the C. And the Y has to be proportional to the X. So in other words, in this drawing, in this theorem that you're learning, the theorem about chords, it's saying this. And I'll read it to you and then I'll show you. If two chords intersect in the interior of a circle, then the product of the length of the segments of one chord is equal to the product of the length of the second chord. So watch carefully. In other words, W times X, because that's the whole chord, right? That's that chord, is equal to Y times Z. Why? Look. Y is in this triangle and is proportional, and Z is in this triangle and proportional. Does that make sense? And W and X. So that is what you're doing. So if there are two chords that intersect, then you can solve using this right here. Okay, so if there are two chords that intersect, then you can solve using them by multiplying the two sections of the chord together. So let me give you an example. All right, so let's take this 9. Now let's make this one 10, and this is 15. So how would we solve for X? Well, 9 times X equals 10 times 15. Divide by 9, divide by 9. X equals 50 over 3. Like how I did that. Isn't that cool? All right. All right, so all you're doing is multiplying across. Let's do another example. Here we go. X plus 10. This is 24. And this is X. And this is 9. So how do we solve this? Here we go. First off, it's going to be 9 parentheses x plus 10 equals 24 times x. Now what? 9x plus 90 equals 24x. Minus 9x, minus 9x. Crosses out, 90 equals 15x. Divide by 15, divide by 15. X equals what, class? 6. That's correct. So once you find your 6, then you can plug back in to find 6 plus 10 is 16. And there's your answers. All right, so if it's a chord and they intersect, then you just multiply the two sections of that chord together. All right? Awesome. Now, let's talk about secant. So that was chord. What about secant? All right. So it says this: if two secant lines intersect in the exterior of the circle. So we have two secant lines intersecting outside the circle, right? Then the product of the length of one secant line and its exterior is equal to the product of the second and its exterior. So watch carefully. They're going to say this. So I'm going to make this x, y, a, b. So this is secant lines that intersect. Okay, here we go. The whole thing, a plus x, times the exterior, what's outside, so that's a, equals the whole thing, x plus b, or y plus b, times just the outside. So it's the whole outside. Whole outside. And you can prove this by making these into triangles. All right? And you make them into triangles, and then that tells you, and that's how you can do that. We're not going to go into that. All right? So the whole times the outside, whole times the outside. Any questions on that? Good. The third one is when it has a tangent. And this one is when it has a secant and a tangent. It has to have both. Secant and tangent in it. All right, so here we go. Now, class, let's look at these two drawings. And I'll put x and y, and we'll just make this a. Okay? Now think about this for a second. What do we do? When we did this up here, when we did these up here, what was it? It was the whole times the outside, right? Everybody got it? The whole times the outside, right? So think about it. It's going to be very similar. The difference is, what does the tangent have? The tangent is the whole and the outside. So really what you're doing is whole outside equals whole times the outside. But the difference is when you put your letters in, x plus y, right, times y equals a times a, which is really a squared. So there's no real difference, and there's nothing, it's the same similar equation solving being done. The only difference is that you have to take into account that the tangent is the whole, and it's also the outside. All right? Any questions on that? So let's do a problem to see, to make sure everybody's somewhat understanding what we have to do here. Okay? All right? So I'll leave those up over there. So you can kind of see them as we do this first problem, okay? So, first drawing looks like this. Oops, sorry. This is y. This is 6. This is 18. This is 10. This is x. Okay, so first off, let's solve for x. Well, how would we solve for x? We're going to use there are two secant lines. So what is our equation? So it's going to be x, the outside, times the whole, which is x plus 10, equals the outside times the whole, which is 6 plus 18. And so we do the math here. So this is going to be x squared plus 10x equals 6 plus 18 is 24. 24 times 6 is 144. Minus 144. So x squared plus 10x minus 144. All right, parentheses, x. Two different signs. So therefore, we are going to have two different signs here. So one's going to be plus, one's going to be minus. So we have to find the factors of 144 that are going to add up or subtract to be 10. So what are the factors of 144? Well, 1 and 144, 2 and 72, 4 and, off the top of my head, it is still going to be a big number, 36. Let's do 6 is 24. 8 is, see, 8 goes in how many times? 18. Oh, there we go. 18 minus 8 is 10, right? So it's going to be minus 8 plus 18. And so there's our two answers. Okay? There's our two answers. So our answer for our question for x is x equals 8. Because this is a negative number. Okay? So your answers are x and negative 18. So therefore that cancels out and your only answer is 8. So x is 8. Now how would I find y? Well, let's talk about it for a second. We can find y the exact same way that we just did over here. So y squared, y because it's the outside times the whole, equals 144. Well, how do I know that? Well, see all this work here? This side, this one was 144, right? 6 and 18, right? So therefore y equals 12, and there's my final answer. All right? So, this is not going to be easy, but any stretch of imagination, but it's going to be good for you and challenge your brain to think and learn and grow.